Welcome back. Today we're going to look at section 4.6, the first day. The main focus of 4.6 is the new topic called completing the square, but we're going to build up to that, and today we're going to look at solving quadratic equations by square rooting and then looking at simplifying some radical expressions along the way. In section 4.5 we covered the first two ways of solving quadratics, which was factoring and solving using the zero product property, and we also talked briefly about graphing and finding the x-intercepts. Today we're going to cover two more methods for solving. We're going to solve by square rooting, and then in our second half of section 6 we're going to look at the fourth method. So solving by square rooting. This method can be used when the equation doesn't have an x term in it. So typically our quadratics are ax squared plus bx plus c equals 0. If that bx piece is not there, we can solve by square rooting. So what do we have to do to solve with square rooting? We have to isolate the squared term. Sometimes it's just a plain x that's being squared, sometimes it's a whole quantity being squared. Once we have that isolated on one side, we can square root both sides. Make sure you remember that there is always a positive and negative when we square root. We have to consider both options. And sometimes we will end up with a radical expression for our answer. Make sure we simplify that, pull any perfect squares out. All right, so our first example, we have x squared minus 81 equals 0. If we're solving by square rooting, we would isolate the x squared term by adding the 81 to the other side. So now we have x squared equaling 81. And then our technique says to undo that square, we have to square root. Whatever we do to one side, we have to do to the other. And we will always, whenever you draw a square root symbol in, you always have to consider both the positive and negative root. So we will get out for an answer x equals positive or negative 9. And if you check that, plug it back in. When we square a 9, we get 81. Subtract 81, we get 0. If we put a negative 9 in and square it, we also get 81, and subtracting 81 gets us to 0. So two solutions, positive and negative 9. On our second example here, we have to isolate the x squared. This is going to require two steps. Our first step would be to add the 72 to the other side. Our next step would be to divide out the 2. So now we have our x squared by itself. It's equal to 36. And when we square root, 36 is a nice perfect square. So we will get x equals positive and negative 6. They won't always be nice perfect squares. All right, example 3. Isolating our x squared term. So we're going to add 150 to the other side. We're going to divide out the 3. This time we end up with x squared equaling 50. And 50 is not a perfect square, but we still are going to square root, and we're just going to have to break that down. So we end up with x being plus minus root 50. We can split 50 into its factors 25 and 2. So we end up with x equaling positive or negative 5 square root of 2. All right. Go ahead and pause the video and try this next one. When you're finished, turn it back on to check your answer. All right, checking our work. First step, add the 48 to the other side. Second step would be to divide out the 2. So now we're at x squared equals 24. Our next step would be to square root both sides. 24 is not perfect, so we're going to have to split that up. We do have a perfect factor of 4 that goes into 24. So we should get x equals plus minus 2 square root of 6 for an answer. Our next example, we're going to subtract the 80 to the other side. Then we have to divide out a negative 2. So we end up with x squared equaling 40. All right, go ahead and finish this one up and then turn the video back on to check your answer. All right. Square rooting both sides, we end up with x equals plus minus the square root of 40. Breaking that down, we can think of it as 4 times 10. So we end up with x equaling plus minus 2 square roots of 10. All right, I'm going to have you add a couple different examples, and we're going to look at why they are different. So in your notes packet, just add these in the margin somewhere. The first one is 2x squared plus 200 equals 0. And if we start solving this, we would subtract the 200 to the other side. We would divide out our 2. And then we would square root. And when we square root a negative number, remember it's going to come out as an imaginary answer. So we end up with plus minus the square root of 100 is 10. The square root of that negative 1, the negative in front, is an I. So what's different about these is we're getting some imaginary answers. All right, the next one I want you to add. 3x squared plus 60 equals 0. Step 1 would be to subtract the 60 to the other side. Step 2 would be to divide out the 3. And then step 3 would be to square root. So we end up with x being plus minus 20 we can think of as 4 times 5. When we square root the 4, we get a 2. When we square root the negative, we get an I. And we still have a square root of 5 remaining. All right, next one I'm going to have you write down and then pause the video and try it on your own. So 2x squared plus 24 equals 0. Go ahead and try that one. All right, checking your answer. 2x squared should equal negative 24 if we move that to the other side. Still trying to isolate that x squared, we're going to divide out the 2. And then we're going to square root both sides. So x equals plus minus the square root of negative 12. Again, we have to think of breaking that up. Square root of 4 would be 2. The negative is going to come out as our imaginary number there. And we have a root 3 left inside. So you should have gotten x equals plus minus 2i root 3. So the difference between those last 3 that we added is that we are getting imaginary numbers because what we were trying to square root was negative. All right, a couple examples of a word problem. It says the lengths of the side of a rectangular window have a ratio of 1.6 to 1. The area of the window is 2,824.4 inches squared. What are the dimensions of the window? Well, it tells us that it's a rectangle, and it says it's in the ratio of 1.6 to 1. That means for every 1x, the other side is 1.6 of them. So we can list our dimensions as 1x and 1.6x. Now the area of a rectangle is length times width. So if we take x times 1.6x, we should get the area of 2,822.4 square inches. So we really end up with 1.6x squared equaling this. So it's really the same type of question we've been solving, we just have some decimals involved. So grab your calculator and divide both sides by 1.6. We end up with x squared being 1,764. And when we square root that, we have plus minus 42. Now, the one thing I want you to consider in this, we are talking about the dimensions of a rectangle. So because of the context being given, it really doesn't make sense to say our one side is going to be negative 42 inches. So it can't be negative if it's measuring the length of a side. So our only answer is that x is 42 inches. Now, the second part of it, it says, what are the dimensions of that window? So we need to take 1.6 times 42 to get the other side. So this would be the width, and then the length is 1.6 times 42, which comes out to be 67.2 inches. All right. Looking ahead, in the upcoming lessons, we are going to have to be able to use square rooting on more complex functions. If the entire side of an equation is squared, we can use our square rooting method just like we've been doing on the other ones. But notice here, it's not just a plain x squared equaling 16, it's a quantity. But because the whole left side is inside that square, we can go right to square rooting both sides. We still have to consider that plus minus. When we square root something that was squared, it's going to cancel it out. So we really end up with just the x plus 3 left. On the right side, we end up with positive and negative 4. Subtracting our 3 to the other side, we get negative 3 plus minus 4. And now I do want you to figure out what that is. Negative 3 plus 4 would be negative 1. Sorry, negative 3 plus 4 would be positive 1. And negative 3 minus 4 would be negative 7. So we are getting two answers again. It's just we're not getting a plus minus the same value. Okay, so like in our previous answers, we would have things like plus minus 5, plus minus 7. This time we're getting two answers, but they're not consistent. One was x equals 1, and one was x equals negative 7. All right, trying the next one. The whole left side is in a square, so we can square root to undo that. We are going to end up with x minus 6 left on the left side. On the right side, we get plus minus root 45, and we have to break that down. 9 is a perfect square that goes into 45, so we end up with x minus 6 equals plus minus 3 root 5. And our last step then would be to add the 6 to the other side. So x equals positive 6 plus and minus 3 root 5. So that is two answers. One is 6 plus 3 root 5, and one is 6 minus 3 root 5. But I'm fine with you leaving it condensed down like we have here. All right, go ahead and pause the video and try the next one. All right, checking your work. You should have square rooted both sides. We end up with x plus 3 equals plus minus the square root of 20. And then we have to reduce that. We can split 20 into 4 times 5. Square root of 4 is 2, so we get 2 root 5. And then we subtract our 3 to the other side. So negative 3 plus and minus 2 root 5. All right. The last questions that we're going to look at. It says, can we get these to look like the previous examples? If you look at the left side of these equations, you have what we call a perfect square trinomial. If we were to factor that, like we did in the first half of the chapter, our x squared would factor into x times x. Two numbers that multiply to be 9 but add up to negative 6 would be negative 3 and negative 3. So it turns into an x minus 3 squared. And the right side said it was supposed to equal a 2. So now it's no different than the ones we've just been working on. We're going to square root both sides. We end up with x minus 3 equals plus minus the square root of 2. There are no perfect squares in 2, so we can't reduce that at all. And then we simply are going to add the 3 to the other side. So we get 3 plus minus root 2. Our next one, 4x squared plus 12x plus 9. Again, it's a perfect square trinomial. The 4x squared we can split into 2x and 2x. The 9 we can break into 3 and 3. And if we check insides and outsides, we'll add up to the 12x that we need in the middle. So we really have 2x plus 3 squared, since we have two identical factors. And now we can square root both sides. So we end up with 2x plus 3 equaling plus minus 2. We're going to subtract the 3 over. and then we're going to divide out the 2. Now, I do want you to simplify that if possible. This one is able to be simplified. So negative 3 plus 2 would be negative 1 with a 2 for our denominator, and negative 3 minus 2 would be negative 5 divided by 2. So we're still getting 2 answers. Simplify them as much as possible. All right, I'm going to have you add one last question. X squared plus 10x plus 25 equals negative 16. We can factor the left side into x plus 5, so it becomes x plus 5 squared. When we go to square root, we are square rooting a negative. Remember, that's going to turn into an imaginary answer. So we're going to get plus minus 4i on the right-hand side, and on the left, just x plus 5. The square and square root cancel each other out. So to simplify this, or to solve for x, I should say, we're going to subtract the 5 to the other side, and we can't really do any more than that to simplify. So our answer is negative 5 plus 4i and negative 5 minus 4i. All right, so for homework today, you guys are going to be working on 2 worksheets. You should have one labeled 4.6a. You're going to do that whole thing. And then find worksheet 4.8a, and I'm going to have you do 1 through 12 on that one. Should just be the front side of that worksheet. The 4.6 is a goldenrod color, and the 4.8 is a blue worksheet.